Section 7.4, solving problems involving independent events. That means the fact that one thing happened doesn't affect the chance of something else happen. For example, if you flip a head and you get a head or a tail, you can flip another coin and you're still got just as good a chance of getting a head or a tail for the next chance. Or if you take a ball from a bag and then you put it back in, you got exactly the same chance that you will pick that ball out again. Okay, sometimes you only got two events happening. For example, doing a spinner and rolling a die. Sometimes you might have more than two events. For example, in this case, I might use a tree diagram to show heads or tails, and then maybe flipping a quarter afterwards, and then maybe flipping a dime. So I'm going to look at this one right here. Sometimes there are more than two events happening. Okay? So I'm going to look at the dime, the quarter, and the spinner. So let's start with the dime. What are the two possible outcomes for the dime? Well, if I start with the dime, I've got a chance of getting a head or a tail. Okay, so let's say I get a head, and then I flip the quarter afterwards. What are the possibilities I could get with the quarter? Well, I could get a head with the quarter or a tail with the quarter. Now, let's say I got a dime at the beginning. I could also get a head or a tail for the quarter. And finally, let's say I have a spinner, and this spinner has four possible outcomes. So I've got the dimes outcomes, then I've got the quarters, and now I got to do the spinners. So let's say I get a head the first time, a head the second time. Out of these four spinners, my four possible outcomes are blue, green, red, or orange. So again, I can do the exact same thing, and I could get blue, red, green, and orange for each possible event. So let's say I get a tail in this one. I could get blue, red, green, and orange for that one as well. Like that. And I could get it again for this one. Blue, red, green, or orange. Four possible outcomes for the spinner. And finally, of course, I could get blue, red, green, and orange for the last one. Okay? So, looking at this, what are the possible outcomes? Well, I could get starting off here, I could get a head, blue. So I could get H, H, B. I could have gotten head, green, or head, red, or head, orange. So that's my possibilities just looking at this batch up here. Now, looking at this one here, I could have got a head, tails. So I could have got a head, tail, blue, head, tail, green. So head, tail, blue, head, tail, green, head, tail, red, and head, tail, orange. Going down even further, I could have got tails on my first turn. And then I could have got tails, heads, blue. Or tails, head, green. Or tail, head, red. Or tail, head, orange. And the other way, I could have got tail, tail. So it would have been tail, tail, blue. Or tail, tail, green. Or tail, tail, red. Or tail, tail, orange. So as long as you take it one step at a time and say deal with just this batch, And then, after you're done with that batch, you can deal with the tail part of it, and then just write out your possible outcomes. You should have no problem figuring out all the possible outcomes you could get. Now looking at that chance, what's the probability of tossing a head on the dime, a tail on the quarter, and a red on this guy? So I'm going to put that in proper format. So what's my probability of a head and followed by a quarter, another head, oh sorry, a tail, and a, let me see, red. Well, let's see, which one is head, tail, red? So head, there's head, tail, red. So there's one chance out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have one chance out of 16 that it will be head, tail, and red. Now, that's the way you can do it by drawing a diagram. There's another way you can work it out, and that is by using a little bit of mathematics, a little bit of good old-fashioned numbers here. All right, so what was the chances of drawing or flipping and getting a tail with the dime, or a head with the dime? You had a 1 in 2 chance. What was the chance of getting a, on the quarter, the head? It was only 1 in 2 chance. That's for tails or dime or heads. And what was the chance in the spinner of getting the color red? Well, that was 1 in 4, because there's only one red out of 4 chances. There's only one tail out of 2 possible outcomes. There's only one head out of 2 possible outcomes. So the way to figure out what your chances are when you put them all together is simply to times them together. So times the tops together. So what's 1 times 1 is 1, times another 1 is 1. Now multiply the bottoms together. 2 times 2 is 4. 2 or 4 times 4 is 16. So when you have 2 or more events, in this case it was 3, all you have to do, if they're independent events and one of them doesn't affect the other, is simply multiply them together to find out what your chances are. So let's say I had this. Let's say I had a dime and a quarter and a die. Okay, what's the chances in a dime when I flip it? It's going to be a head. So let's a head. The chance of a head is, or the probability of a head is, 1 out of 2. What about a quarter? What's the chance of getting a head? 1 out of 2. And what's the chance of getting a even number out of one die? Well, the probability of even is 3, because there's 2, 4, 6 out of 6. Now, if I want to find out what's the chances of getting all these 3 things together, I simply times them together. So 1 on top times 1 there is 1, times 3 is 3. Times the bottoms now, 2 times 2 is 4, 4 times 6 is 24. So I've got a 3 in 24 chance. I could reduce this here to 1 out of 8 if I wanted to lower my fraction by dividing the top and the bottom by 3. But that's my chances, so it's not a very good chance of getting all these 3 things to happen that I want. Of course, they are all things that if you put them back, the stuff gets returned. Now, looking at card problems, because you're going to see card problems quite a bit, Okay? It's all going to be about you just can't draw every single possibility in cards. It's impossible. But you got to remember one thing about cards. Okay? There are 52 cards in a deck. Okay? There are 26 black and 26 red. Remember, the black ones are called spades and clubs. And of course, the red ones are hearts and diamonds. So this is what we got. So half of them are red, half of them are black. Now in each deck, so these are the diamond ones, in each deck you notice you have a ace, king, queen, and jack. They're called face cards. Of course, the rest of them are just regular suits. 10, 9, 8, 7, 6, 5, 4, 3, 2. So you'll look at 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards per suit. In other words, 13 diamonds, 13 hearts, 13 clubs, and 13 spades. So it's pretty easy to use that knowledge to figure out mathematically some of the problems. So here's what we want. We want the probability of red, and then the probability that it will be a jack afterwards, and then the probability of drawing a spade. So we want all these three things to happen if we draw 3 cards and we return each card after we're done. Well, let's see. What's the chance of getting red out of all the cards? Well, we said 26 were red out of 52, which, funny enough, is the same fraction as 1/2. What's the chances of getting a jack? Well, there are 4 jacks. There's one jack of diamonds, jack of clubs, jack of spades, jack of hearts. There's 4 out of 52. And of course, if you want to divide each one here, okay, it would be 1 out of every 13 are jacks. And finally, spades. We know that 13 out of 52 are spades. Or, of course, that works out to 1 out of every 4 if you reduce that fraction. So divide this top by 13 and divide the bottom by 13, and you will end up to the spades will be 1 out of every 4. Now, what are your chances of getting all 3? You got to times them together. So let's times the top together when we're multiplying fractions. 1 times 1 is 1. Times another 1 is still 1. So you got 1 chance out of 2 times 13 is 26. 26 times 4, well, I can simply punch that in if I'm not sure. So 26 times 4 is 104. So my chances of getting a red and then putting it back, and then getting a jack, and then putting it back, and then getting a spade, so all 3 of these events happening, is 1 chance out of 104. That's not even 1%. That's less than 1%. Of course, if I didn't return the cards, then I certainly would be lowering my chances. But in this case, we're just going to say we return the card, so there's always going to be 52 cards left in the deck every time.